Good evening, friends. Welcome to your favorite YouTube channel, Unacademy GATE MEPIXE. This is your educator Aprup Rao, and you are watching the lecture series of Strength of Material in the booster batch for GATE 2021. 100 days crash course completely free on this very YouTube channel. Now, all of you are welcome here. Hit the like button and share with your friends. Share the link with your friends. Hit the like button, guys. Good evening, Rohit. Good evening, Pawan, Kiran, Shalini, Deepak, Suhail, Gupta ji, Raj, Akash, Sahim, Manish. Welcome, everyone. Welcome, welcome. I welcome all of you. And this is the 5th lecture of the series of Strength of Materials. And today we are going to see a very important topic from theory's point of view, which is stress strain diagram. Sorry for this. So sorry for this. One sec. Sorry. Stress strain diagram. So today we are going to learn stress strain diagram for ductile materials, stress strain diagram for brittle materials, and we are going to see some amazing concepts related to stress strain diagram like true stress strain, power law, etc. So you might have not seen this maybe, but today I am going to discuss everything related to stress strain diagram. Okay. Now, beta, those of you who are watching me for the first time, let me introduce myself. My name is Aprup Rao, All India rank 320 from GATE Mechanical. I've done my MTech from IIT Kharagpur and my specialization for MTech was Mechanical Systems Design. Then I was recruited by Mahindra & Mahindra and I was placed at their R&D center, Mahindra Research Valley, located in Chennai, where the cars and tractors of Mahindra are designed. So I have worked in the field of design for 2 years as deputy manager. Then I quit my job and I started teaching. So I've been teaching for more than 6 years now, and I teach the subjects related to design, SOM, MD, EM, TOM. But I'm not here because of this. I am here on this very channel because of my love for teaching, because of my love for the subjects of design. And if you are following my lectures regularly, I can bet, I can be very sure that you will also fall in love with design. Now, a very important announcement. We have this crash course, 100 days crash course for GATE 2021 aspirants, where we are going to cover the entire syllabus in 100 days. So it was started on 1st of October. If you don't know the schedule, let me tell you again. Heat transfer from 7 AM to 8:30 AM by Sandeep sir. Engineering mechanics 8:45 AM to 10:15 AM by Alok sir, and strength of materials 7:30 PM to 9 PM by me from Monday to Friday. So I am going to cover the entire syllabus of strength of materials. I will be here every day from Monday to Friday at 7:30 PM dot. All I want from you is your live attendance. All I expect from you guys is your live attendance. So we have a lot of free initiatives on our channel. We have started a crash course, a 100 days crash course. We are also starting a weekend batch for GATE 22, GATE 23 aspirants. Those of you who are preparing for GATE 22 and 23 and who want to start your preparation, but you don't want to miss your academics also, you don't want to miss your college lectures also. So beta, you can start your preparation on weekends, Saturdays and Sundays. So beta, we are soon launching a weekend batch. From this very weekend, we are starting that batch. So we have a lot of free initiatives for you guys. All we want from you is your dedication, your support, your live attendance. So you have to be live every day on this time for attending these lectures. You have to take full advantage of these free initiatives. And if you can, then please share these links with your friends also, with your groups also, with your classmates also, so that they can also take the advantage of these free initiatives. That's all we expect from you guys. Okay. So beta, if you keep supporting us, if you keep coming to these live lectures, then we will be doing more and more on this very channel. We will be taking more and more classes. We will be starting more and more batches. So it will be all for your benefit only. If you want for us to keep going like this, if you want for us to keep making these videos, then all you need to do is come live every day at this time and if you can, then please hit the like button on every session and share the link with your friends. Okay, all right. Now if you want to download my lecture notes, I have made it very easy for you. I upload on all my lecture notes here on tinyurl.com/approve10. just open this in your web browser like facebook.com, youtube.com. open tinyurl.com/approve10 and you will find folders of different subjects where I have uploaded the ebooks. And if you want to download the lecture notes, I have made Excel sheets of different subjects. For example, this is the Excel sheet of machine design, mechanics, strength of material. If you open this Excel sheet, you will find that I have uploaded the YouTube class link and the PDF link lecture by lecture. So I have taken 38 lectures for engineering mechanics, complete syllabus. You can see the YouTube classes and you can download the PDF of those classes. Then I have also taken complete syllabus of machine design. You can see the YouTube classes, you can download the YouTube classes, and right now I am taking strength of materials in this booster batch for GATE 2021. So as I will keep on taking the classes, I will put the YouTube class link and the PDF link on this Excel sheet. So after every lecture ends, within 10 to 15 minutes, I am updating this link. So you can download the PDF by going to these Excel sheets. I hope everyone knows about this by now. I hope everyone is downloading the PDF from here. I hope everyone is enjoying these Excel sheets. So these are like digital books for you. You can refer them as digital books. So this is the digital book of engineering mechanics, digital book of machine design, completely free, full syllabus. And right now we are preparing the digital book for strength of materials also. Okay, so beta, you will have the digital book, complete syllabus book of all the subjects of mine. Okay, so this is a small gift from my side to you for following me, for loving me like this. Okay, and I have another good news for you. I have my own Telegram channel, which is Unacademy officially passed Telegram channel. So what you can do is just go to your Telegram app, search for Approve10 and join this Telegram channel. Or if you have a QR code scanner, you can scan this QR code also and it will show you the link of my Telegram channel. So beta, join this Telegram channel and you will get the notification of all my classes whenever I will be live on YouTube or whenever I will be taking free special class on Unacademy. You will get the notification, you will get the link. And if I have to share any relevant study material, then I will put that study material here in this Telegram channel. Okay, I am also putting everything on tinyurl.com/approve10, but if I have some additional things to share, then I will put it here on this Telegram channel. So join this Telegram channel right now. Okay, so let's start our lectures. So beta, we have completed introduction to stress, we have completed introduction to strain, and we started material properties yesterday, where we saw what are different types of material, what is elastic constant, what are the different types of elastic constants. We saw the relation between stress and strain according to Hooke's law, and we saw a very amazing table of minimum number of independent elastic constants. I explained the entire logic behind that table, which is not mentioned in a lot of books, but that table is very important from exams point of view. So you can watch that lecture after this lecture ends if you have not seen that. Okay, so beta, in that lecture or in that chapter only, we will continue our discussion today on stress strain diagram, which is a very important topic. You will get theory questions from this topic and you will also get numerical questions from this topic. Okay, this is also important from numerical point of view. There are some numericals recently in GATE from stress strain diagram. Okay, so stress strain diagrams are very important to understand from theory point of view as well as numerical point of view. Okay, so let's understand entire stress strain diagram, whatever concepts are there for stress strain diagram. Okay, so beta, hit the like button and share the link, hit the like button. Yes, yes, yes. तो चलो चालू करते हैं, चलो शुरू करते हैं. So beta, first of all, we will discuss simple tension test. In order to understand what is stress strain diagram, we have to discuss simple tension test. Now, what is simple tension test? There are several tests conducted in laboratory in order to find the material properties, and simple tension test is one of those tests. It is a test performed in laboratory in order to find material properties. And what do we do in this test? In this test, we make a specimen of this shape. It is like a dumbbell. So whatever material you want to find the material properties of, you will make a standard specimen of that material. For example, let's say I want to find the material properties of steel. So I will make a specimen like this of steel. Okay, it is like a dumbbell. You can see that here and here the area is more. Okay, so this part is in the grip of these jaws. You can see this is universal testing machine. This is known as universal testing machine, also called as UTM. Okay, so in this universal testing machine there are jaws. This is the upper jaw, this is the lower jaw. So you will fit this part inside the jaw, and then this universal testing machine will start applying tensile load like this. We'll start applying tensile load, and we will keep on increasing this load until the material fractures like this. Can you see? Can you see? The material is fractured. So this is known as simple tension test. So what we are doing, we are making a specimen of the material, we are putting it in universal testing machine, we are applying the load until it fractures, until it breaks. And what we are going to do is, we are going to find the load versus deflection curve. We are going to find the value of deflection, elongation for every load. Okay, so let's say this is the load P. Let's say this is the load P. Okay, now what we do is, we mark these points on the length of the specimen. Okay, and what we do is, we fix a particular length. Let's say this is the length L. This is known as gauge length. Okay, this is known as gauge length. So we have several markings on this specimen. So let's say between this marking and this marking, I am fixing a particular length. This is the gauge length. Okay, now what I am going to do is, as I keep on increasing the load, this specimen is going to elongate, right? जैसे जैसे मैं लोड की वैल्यू बढ़ाता जाऊंगा, ये लेंथ भी बढ़ती जाएगी, right? So I will calculate, I will find the change in length with respect to the load. For example, let's say at 1 kilonewton the change in length is 1 mm, then at 2 kilonewton the change in length is 2 mm, at 3 kilonewton the change in length is 3 mm. So beta, I am going to find out the values of change in length corresponding to various loads, okay? Then what I am going to do is, I am going to draw a graph between the load and the deformation. This is the load and this is the deformation. And for example, let's say my curve is like this. This is just an example, okay? For example, let's say I am getting a curve like this. Now what is this? This is known as load deflection curve. But we are not interested in the load deflection curve. What we are interested in is the stress strain curve. So I will convert the load deflection curve into stress strain curve. Now how I am going to do it? How I am going to convert load deflection curve into stress strain curve? Let's say the area of the specimen is A. Let's say the area of the specimen is A. So if I divide the value of P by area, then what I am going to get? If I divide the value of P by area, I am going to get sigma, right? I am going to get sigma. Let's call it A naught. ठीक है? इसको हम बोल देते हैं A naught, इसको हम बोल देते हैं L naught, because this is the original area and original length. So beta, I will call this sigma equal to P by A naught. And if I divide delta L by the original length, then I will get the strain. So beta, load divided by area is giving you stress, and change in length divided by original length is giving you strain. So now my curve is converted into stress strain curve. The load deflection curve is converted into stress strain curve. Now understand this thing. The original area and the original length is constant value, right? So beta, your P is changing, your delta L is changing, but your original area and original length are constant. So your sigma is directly proportional to P and your delta L is directly proportional to epsilon, because these things are constant, है ना? ये चीज तो constant है, A naught is constant, L naught is constant. So sigma is directly proportional to P, epsilon is directly proportional to delta L, means you will get the same shape of curve. Means if this is straight line, this will also be straight line. If this is going up, this will also be going up. If this is coming down, this will also be coming down. Your shape of load deflection curve and shape of stress strain curve will be same, or you can say stress strain curve will be proportional to load deflection curve. ये जो curve है ये इसके just proportional रहेगा, बस दोनों का scale different रहेगा, right? Why? Because I am dividing the values of P by a constant value. I am dividing delta L by a constant value. So the shape of stress strain curve will be proportional to the shape of load deflection curve. Okay, is this clear? Is this clear? Yes, yes, very good guys, very good. So now beta, I will calculate the values of stress and strain for different materials from the stress strain curve, and using that we can find out different material properties. Why we are doing this? What is our objective by drawing this stress strain curve? Our objective is to find the material properties. We have certain material properties which we can calculate from this curve. So that is the final objective. That is why we are drawing this curve. ये curve draw क्यों कर रहे हैं? इस curve को draw करने का मकसद क्या है? उद्देश्य क्या है? लक्ष्य क्या है? हमारा उद्देश्य है, our objective is to find certain material properties which we can calculate from this diagram. Okay, so first we will understand how this diagram looks for different materials, and then we will understand how different material properties are calculated from this curve. पहले ये समझते हैं कि अलग अलग मटेरियल के लिए ये कर्व दिखता कैसा है, और फिर हम देखेंगे कि इस कर्व से मटेरियल प्रॉपर्टीज हम कैसे कैलकुलेट कर सकते हैं. ओके, नाउ वी कैन डिवाइड ऑल दीज मटेरियल्स इनटू टू कैटेगरी फॉर स्ट्रेस स्ट्रेन कर्व: ductile material and brittle material. In order to understand how the stress strain curve is drawn for different materials, we can divide all these materials into two categories: ductile and brittle. The stress strain curve of ductile material is completely different. The stress strain curve of brittle material is completely different. So these are two different categories of material. Now in order to understand what is the difference between ductile and brittle material, first you need to understand the difference between elastic deformation and plastic deformation. Okay, so let me explain the difference between elastic and plastic deformation. Okay, सबसे पहले तो मैं आपको समझा देता हूं what is the difference between elastic and plastic deformation. Now beta, in order to exactly understand what happens inside the material, you need to know the concepts of material science. So we are not going to get into the depth of material. हम लोग घुस के अंदर नहीं देखेंगे, but in short I will try to explain the difference between elastic and plastic deformation, because this is necessary in order to understand the difference between ductile and ब्रिटल मटेरियल. ठीक है, डक्टाइल और ब्रिटल के डिफरेंस को समझने के लिए ये डिफरेंस पहले समझना जरूरी है. ओके, सो लेट मी एक्सप्लेन व्हाट इज इलास्टिक डिफॉर्मेशन. What is elastic deformation? Okay, so let's say we have these atoms inside the material which is connected to each other by means of bonds, okay, which is connected to each other by means of bonds, okay. And now I am applying a tensile load. So under this tensile load what happens, if the load is very less, agar load ki value kam hai, if the load is less, then these bonds are not broken. The bonds are not broken, the atoms are still connected by the bonds, but these bonds are stretchable, they are like springs, so they will stretch. ये क्या हो जाएंगे, अपनी अपनी जगह से थोड़ा हिल जाएंगे, like this. They are going to elongate like this, but the bonds are not broken. So this deformation is temporary. This deformation is temporary and small, very small, okay, because the bonds are not broken, so the atoms cannot go from the atoms cannot move by a very large distance. Atoms जो है बहुत दूर नहीं जा सकते, they are going to stretch by a very small amount, okay. तो काफी छोटा सा deformation मिलेगा and it will be temporary. Why it will be temporary? Because the moment I will remove my load, these bonds will again regain their size. They are like springs. So if you stretch a spring, it is going to elongate, but as soon as you remove the load, it is going to come back. So just like that, if I remove my load, the atoms will come back to their original position. So this deformation is temporary and this deformation is small. So beta, do you understand these 2 points about elastic deformation? Yes. Now let's understand permanent deformation or plastic deformation. Now understand what is plastic deformation. So in case of plastic deformation, the load is very large. So when the load is very large, what happens is these atoms move from one place to another place because the bonds are broken. If the load is very large, then the bonds between the atoms are broken and the atoms move. This atom will move to here, this atom will move to here, this atom will move to here. Okay, these atoms will move like this. ये ऐसा, ये ऐसा, ये ऐसा, ये ऐसा. These atoms are going to move like this. Okay, this is just one type of movement. There are different types of movement of atoms. Okay, I am just giving you an example. Okay, so these atoms are going to move like this. Okay, now this deformation is permanent. Why this deformation is permanent? Because the bonds are broken, the atoms have moved on and they have formed a new bond. Bonds जो हैं वो टूट चुके हैं, अब atoms अपनी जगह से move कर चुके हैं और नए bond बना चुके हैं. So even if I remove the load, the atom is not going to come back. Even if I remove the load, the atom is not going to come back. So this is a permanent deformation and this is large. This deformation is large. So is this point clear to you? Is this point clear to you that in case of plastic deformation, the deformation is permanent and the deformation is large? So this is the basic difference between elastic deformation and plastic deformation. Is it clear to you? Is it clear to you? क्या ये point clear है आप सबको? Is it clear to you? Yes. This difference is very important in order to understand ductile and brittle material, in order to understand the difference in ductile and brittle material. Now understand the difference in ductile and brittle material. अब ductile versus brittle material समझ लेते हैं. So what is the difference between ductile materials and brittle materials? What is the difference exactly? So understand, in case of ductile materials, what happens is when I apply the load, there is elastic deformation. Then if I increase my load, there will become plastic deformation. There will be plastic deformation which is going to be very large, and then the material is going to fracture. After that, the material is going to fracture. So do you understand what is happening? First there will be elastic deformation, then there will be plastic deformation, and then the material is going to fracture if I keep on increasing the load. मैंने load लगाया, initially load was small, elastic deformation. Then the load became large, plastic deformation, and then I am applying the load, I am increasing the load, increasing the load, increasing the load, the material will fracture. Okay. But in case of brittle material, in case of brittle materials, there will be elastic deformation, and then the material is going to fracture. There will be no plastic deformation in case of brittle material. Now due to this, what happens? In case of ductile material, the total deformation is the sum of these two, right? Total deformation is sum of these two. So this total deformation is equal to or greater than 5% of original length. But in this case, the total deformation, is less than 5%. Means, let's say I have a 100 mm length of rod made of ductile material. So if I keep on applying the load, and then when it will break, the length will be more than 105 mm. 5% से ज़्यादा का deformation हो रहा है, मतलब ductile material. But if I am applying the load and there is only 1 mm deformation or 2 mm deformation, means it is a brittle material. What are the examples? Ductile material के examples क्या होंगे? Steel, copper, aluminum. These are the examples of ductile material. What are the examples of brittle material? Glass, cast iron, wood. These are the examples of brittle material. So in case of brittle material, there is no plastic deformation. The deformation is only elastic in nature, which is very small. So that's why there will be very negligible deformation. If I keep on applying the load, it is going to break and you will not even notice that there was deformation. आपको पता भी नहीं चलेगा कि deformation हुआ या नहीं. एक example लेते हैं. Let's assume glass. So if I apply a tensile load on glass, you will not even notice whether the glass is expanding or not. You will not even understand whether there is deformation in glass or not. You will feel like it is not moving at all. It is not elongating at all. And then it will break. So that is brittle material. But if I have a rod of steel and if I apply the load, you can see that the steel is elongating. It is seen, it is visible because the deformation is very large. So that is the difference between ductile and brittle material. So if someone asks you how you will determine whether a material is ductile or brittle, what you are going to do? You are going to apply the load on the rod of both the materials and you will see whether the deformation is greater than 5 or less than 5. If it is equal to or greater than 5%, then it is ductile material, and if it is less than 5%, then it is brittle material. So that is the difference between ductile and brittle material. Is it clear to you? Yes? Very good, beta. Very good. So beta, we have understood the difference between ductile and brittle material. Now, as the nature of ductile and brittle material is completely different, दोनों का nature एकदम अलग होता है, their stress strain diagram is also completely different. So we will see the stress strain diagram of ductile materials and then we will see the stress strain diagram of brittle materials. Okay, so one by one we are going to consider the stress strain curve of both. We are going to understand what are the different points in their curves. Okay, so let's first draw the stress strain curve for ductile material. Now this is a very interesting curve. There are a lot of concepts to understand in this curve, but I want you to understand one thing. Right now, whatever stress strain curve we are drawing, we only need to understand what are the different points and how we are going to use them to calculate the properties. That's it. We don't need to get into the details of material. We don't need to get into inside of material. We don't need to get into the details of the mechanism of deformation. Because if you want to understand those things, if you want to understand the mechanism inside the material, what is happening inside the material, then you need the concepts of material science. You need the concepts of material science, and it will take a lot of time discussing those concepts. So that's a completely different subject. You have stress strain curve in material science also. Material science के subject में भी stress strain curve आप पढ़ते हैं. There your objective is different. There your objective is to understand the mechanism of deformation, how the material is deforming, what is happening inside the material, how these atoms are moving, how these bonds are moving. So that is different. This is different. So here you need to understand the curve macroscopically, not microscopically. Microscopically material में घुस के नहीं देखना है, material के अंदर झांक के नहीं देखना है. तो इसीलिए बेटा don't get into the details. आप बहुत ज़्यादा डिटेल में मत घुस जाना कि ये कैसे हो रहा है, ये क्या हो रहा है, ये मुझे जानना ही है. However I can explain, I will try to explain. मैं जितना ज़्यादा हो सके उतना explain करने की कोशिश करूंगा. But there are some things which I cannot explain because you need the concepts of material science to understand those concepts. So that's why beta, whatever I am explaining, just understand that. जितना मैं बता रहा हूं बस उतना समझो. बहुत ज्यादा आप अगर दिमाग लगाओगे, waste of time. Okay, so let's understand the stress strain curve from strength of material point of view, not material science point of view. Okay, so on y-axis I am going to draw stress. Okay, and the unit is usually megapascal. On x-axis we draw strain, or sometimes we draw percentage strain. Now what is percentage strain? Percentage strain is nothing but 100 times of strain. Okay, strain में अगर मैं 100 multiply कर दूं, I am going to get percentage strain. Now why we are multiplying 100 in strain? Understand this. We are multiplying 100 in strain because the values of strains are very small. Strain की जो value होती है वो बहुत छोटी होती है. They are in the range of 0.001, 0.002, 0.003. So in order to increase the scale, we sometimes multiply 100 in strain and we draw percentage strain. Instead of strain, we are drawing percentage strain on x-axis. Is this point clear? ये percentage strain की कहानी clear है? Now why it is important to understand? Why it is important to understand? Because sometimes in questions they will give you percentage strain on x-axis, and if you don't notice it, you will make mistake in the numerical. People have done that mistake. In GATE 2016 or 17, there was a question on stress strain diagram, numerical on stress strain diagram. They gave percentage strain on x-axis and people didn't notice that. लोगों ने वो चीज नोटिस नहीं की, बहुत सारे स्टूडेंट ने उसको नोटिस नहीं किया, and they used the value given on this diagram directly. So their answer was wrong. So that is something which you don't need to do, which you don't want to do. So इसीलिए मैं बोल रहा हूं कि अब आपको जब भी stress strain curve दिया हो, whenever there is a stress strain curve given in the question, always notice whether it is strain or percent strain. If it is percent strain, means whatever value you want for strain, the value given in the curve is 100 times of that. ठीक है, जो actual value है उसको 100 से multiply किया गया है. It is scaled up. Okay, now let's start drawing the stress strain curve. So understand the process. We have made the specimen of the material. Now we are applying the load. Okay, so we start increasing the load from 0. हम 0 से load increase करना start करते हैं. So at 0 load, the stress will be 0, the strain will be 0, right? Now, as I start increasing the load, initially the stress will be directly proportional to strain, or you can say sigma will be directly proportional to epsilon, or sigma will be equal to E into epsilon by Hooke's law. Now what is this? Sigma equal to E into epsilon. This is your Y, this is your X. So Y equal to mx, which is the equation of a straight line. So initially you are going to get a straight line on the stress strain curve. Initially you are going to get a straight line on stress strain curve. So let's say this is my initial point O. Let's say this is my initial point O and this is point A. So what is this point A? This point A is known as proportional limit. What do I mean by proportional limit? Up to this point, the stress will be proportional to strain. Up to this point, the stress sigma will be proportional to epsilon, sigma equal to E into epsilon. Okay? Now, if I increase my load beyond the point A, then this will become slightly curved. And this is point B. This point B is known as elastic limit. Now what do I mean by elastic limit? Up to this point B, the material is completely elastic. Now what do I mean by material is completely elastic? Elastic means whatever deformation you are getting, it is temporary. If you remove the load, the material will regain its size and shape. यहां तक जो भी डिफॉर्मेशन हुआ है, B पॉइंट तक जो भी डिफॉर्मेशन हुआ है, it is completely temporary. If you remove the load, the material is going to regain its shape and size. Now, if I increase the load beyond this point, there will be plastic deformation. And if there is plastic deformation, what is going to happen? Understand it. What is going to happen? Understand it. Let's say I have applied the load up to this point, okay? And I have removed the load. So if I remove the load, the material will come back to this. The stress will become zero, but the strain will not become zero. Why? Because after point B, there was plastic deformation in the material, permanent deformation in the material. So beta, if you remove the load beyond point B, अगर मैंने load हटा दिया, इस point तक लगा के load हटा दिया, what is going to happen? Understand? The material will come back like this. Okay, this is known as unloading curve. इसको हम क्या बोलते हैं? This is known as unloading curve. And what is the property of unloading curve? This line and this line will be parallel to each other. ये line और ये line दोनों क्या रहेंगी? Parallel रहेंगी एक दूसरे के. Now understand, sigma equal to E into epsilon. So in this equation, what is E? It is the slope. So if you calculate the slope of this line, you will get Young's modulus. Similarly, if you calculate the slope of this line, then also you will get Young's modulus. Now understand this point, amazing point. Let's say up to point B, there was 0.01% strain. ठीक है, there was 0.01% strain. Okay, 0.1% strain मान लेते हैं. Okay, let's say up to point B, there was 0.1% strain, and after point B, here total strain is 0.3%. यहाँ तक मान लो 0.1% strain था और यहाँ पे 0.3% strain था. So बेटा, this total strain 0.3% is the sum of elastic and plastic strain, है ना? यहां तक 0.1% का strain था, यहां 0.3% का strain है. So बेटा, total strain of 0.3% is sum of elastic and plastic strain. 0.1% is the elastic strain. 0.1% is the elastic strain. And after B, whatever you are getting is plastic strain. मतलब ये 0.3 को मैं ऐसा लिख सकता हूं, 0.1 plus 0.2. This is what? Elastic strain. This is what? Plastic strain. Do you understand? Up to point B, whatever you got is elastic. After point B, whatever you got is plastic. So at this point, total is 0.3, which is sum of elastic strain plus plastic strain. Now when I remove the load, this elastic strain will become 0, but this plastic strain will remain 0.2%. अगर मैं लोड हटाऊंगा तो इलास्टिक will become 0, but this plastic strain will remain there, so it will move back to 0.2%. So what is this representing? ये क्या represent कर रहा है? This is representing permanent strain. This is representing permanent strain. So do you understand? Do you understand this entire concept, what I am trying to explain to you? At any point, if I remove the load beyond P, beyond point B, at any point, if I remove the load, the load will come back, the curve will come back to this, and this deformation will be the permanent deformation. Now, this is a very important concept. We are going to use this concept in numericals also. ठीक है? Numerical बनाने में ये concept काम आता है. तो B के बाद अगर मैं किसी भी point से, after B, if I remove the load at any point, then the material will move back, the curve will move back like this, and this strain will be the permanent strain. Is this point clear to you? क्या ये point clear है? क्या ये point clear है? Yes. Okay. Okay. चलो. Now, let's say we are increasing the load. We are keep on increasing the load. So what is going to happen? This curve will go up to this point, and suddenly it will drop. This is point C and this is point D. Point C is known as upper yield point and point D is known as lower yield point. Now understand what is yielding. Yield बोलने का मतलब, yielding बोलने का मतलब है, yielding means permanent deformation. Yielding means permanent deformation. Permanent deformation. Okay. Now what happens is, at this point C, the bonds between the atoms are going to be broken, and the material and the atoms will start freely flowing inside the material. जो atoms है वो अब free हो गए हैं और वो flow करना चालू कर देते हैं. This is known as flow because the deformation is very large. So what happens is, as the bond is broken and the atoms start flowing freely, now you don't need to apply any load. The load will become constant. The resistance of the material will become constant, and at constant load, you are going to get deformation. In case of yielding, what happens is the resistance of material. Understand, whatever you are drawing here on this y-axis, it is not the applied load. It is the resistance of the material. Okay, जो P हम लोग यहाँ draw करते हैं, whatever P we draw here, this P, this is not the applied load. This is the resistance. This is not the applied load, this is the resistance of the material. So after this point, what happens is the resistance of the material becomes constant. The material is not able to resist the load anymore. Why? Because now the atoms have become loose and they are freely flowing. Beta, how the material is able to resist the deformation? How the material is able to resist the load? From deformation, right? अब deformation जो है वो free हो चुका है. Okay, deformation has now become free. The body is the material, the atoms are starting to flow freely. So due to this, the resistance of the material becomes constant. So now the resistance will not increase, but the deformation is increasing. The atoms are flowing freely. So beta, you will get a almost horizontal line. You will get an almost horizontal line, and this process of plastic deformation under constant load is known as yielding. तो yielding का मतलब क्या होता है? Some people feel that yielding means permanent deformation. No, there is a small difference. Yielding is not only permanent deformation. Yielding means permanent deformation under constant load. This process is known as yielding. Permanent deformation under constant load. So beta, this is the upper yield point, this is the lower yield point. Now what is upper yield and lower yield? At point C, the material starts to yield. So this is the load required to start yielding. ये वो लोड है जो यील्ड को स्टार्ट करने के लिए चाहिए, मींस बॉन्ड्स को ब्रेक करने के लिए चाहिए. बट द लोड रिक्वायर्ड टू कीप द यील्डिंग इज लेस. मतलब एटम्स को फ्री होने के लिए जो लोड चाहिए, एटम्स को मूव करने के लिए उससे कम लोड चाहिए. द लोड रिक्वायर्ड टू फ्री द एटम इज लेस compared to the load required to move the atoms. So that's why the resistance suddenly drops and then it becomes constant. So this is the upper yield and this is the lower yield, and the load has become constant. Now understand what is happening. As the atoms start to flow freely inside the material, there comes a point when they start blocking each other. If you want to understand this concept, understand it using a practical example. Let's say there is an empty box and inside that empty box I have some marbles, okay? So if I shake the box, the marbles will move and they will make sound, right? Now if I increase the number of marbles and if I shake the box, the sound will increase. Now if I keep on filling the marbles and if I keep on shaking it, the sound will start to increase, and then there will be a point when the sound will start to decrease. Why? Because now there are so many marbles inside the box that there is no space for them to move, right? अब अंदर इतने ज़्यादा मार्बल हैं कि उनको मूव करने के लिए जगह ही नहीं मिल रही है. That is what will happen here. After yielding, the atom starts to flow, the atom starts to move. The body gets deformation. But beta, when all these atoms become free and they start moving from here, they block each other's path at one point, and now the material will stop flowing. Now the atoms will stop flowing. Now the deformation will stop. So now if you want more deformation, you have to increase the load. अब अगर आपको ज्यादा deformation चाहिए तो आपको लोड बढ़ाना पड़ेगा. So this curve will start going up. This curve will start going up. So do you understand? The resistance of the material has increased after this point. क्या आप देख सकते हो कि मटेरियल का रेजिस्टेंस बढ़ चुका है? The resistance of the material has now increased because in order to get more deformation, I need to apply more load after this point. So this process of increase in resistance is known as strain hardening. So this is yielding and this is known as strain hardening. So do you understand the concept of strain hardening? Do you understand the concept of strain hardening? Yes, yes. Very good. So beta, strain hardening का मतलब क्या है? Inside the material there is so much strain that the resistance has now increased. Okay. So this curve goes up to point E, which is known as ultimate point. Now what is ultimate point? At this point, suddenly the cross-sectional area of the specimen reduces. Understand it from this diagram. ये diagram आपको दिख रहा है? Do you see this diagram? The cross-sectional area is suddenly reduced. You can see that the cross-sectional area is suddenly reduced in this region. This process is known as necking. The cross-sectional area is suddenly reduced. So this process is known as necking. The cross-sectional area in a particular region, not the entire specimen, in a particular region of the specimen, the cross-sectional area will suddenly reduce, which is known as necking. So beta, due to this necking, what will happen? Due to this necking, the resistance of the material will become less. So now the material will not be able to offer that much resistance. So this curve will start to go down. बेटा यहाँ पे P की वैल्यू कम हो रही है. The resistance is getting dropped. So this curve will start to go down, and after a point, the material will break. Can you see? Can you see? The material has broken, right? So after some time, the material will be broken. So this F is known as fracture point. So do you understand these different points? Proportional limit, elastic limit, upper yield, lower yield, ultimate, and fracture point. Is this point clear to you? Are these points clear to you? Now beta, understand this. Understand this. This point A, B, C, D. These are very close to each other. So I can almost assume them as a single point. I can almost assume that up to this point, there is elastic deformation. So beta, can I say that from here to here, this is the elastic region? Can I say this is the elastic region? Then from here to here, can I say this is the plastic region? Then from here to here, can I say this is strain hardening? And from here to here, can I say this is necking? So beta, you can divide the entire deformation from here to here into 4 regions: elastic deformation, plastic deformation, strain hardening, and necking. So is this entire graph clear to you? क्या ये पूरा ग्राफ आपको क्लियर है? Is this entire graph clear to you? Elastic region, plastic region, strain hardening, and necking. Is this entire graph clear to everyone? Yes. Yes. Thank you so much, Signaanjali. Thank you so much. Thank you so much, Deepak. चलो चलो, तो बेटा ये पूरा ग्राफ जो है आपको याद रखना है. You need to understand what is elastic region, plastic region, strain hardening, and necking. Okay, you don't need to get into details. What is happening here? What is happening here? Why this is going up? Why this is going down? You don't need to get into very detail. You don't need to get into the mechanism of deformation, but you need to understand this. Okay. Now, can you see that the total deformation is huge? From this point to this point, the total deformation is very large. So this is known as a ductile material. Okay, this is the stress strain curve of a ductile material. Okay, but this is not the stress strain curve of every ductile material. Understand, this is the stress strain curve of a low carbon mild steel. This is the stress strain curve of a low carbon mild steel. Not every ductile material shows these points. For example, if I draw the stress strain curve of aluminum, then the stress strain curve is a little different. Stress strain curve of aluminum is a little different. Understand it very quickly, understand it. Okay. So let's say we are going to draw the stress strain curve of aluminum. So I will get a stress strain curve like this. Now can you see what is the difference here between the stress strain curve of low carbon mild steel and the stress strain curve of aluminum? What is the difference here? क्या difference आ रहा है आपको समझ में आ रहा है? What is happening? So beta, if you see the stress strain curve of low carbon mild steel, you can clearly see the yielding process, right? You can clearly see the plastic deformation under constant load, but here you cannot see that. Here you cannot see plastic deformation under constant load. So beta, here what happens is the material becomes elastic to plastic suddenly. There is a sudden change in elastic to plastic region. So that's why we are not getting a permanent deformation under constant load. यहाँ पे what was happening, the material was becoming elastic to plastic gradually. There was a gradual change. Hello, hello, hello. Okay, okay, okay. So is the voice audible now? अभी आवाज आ रही है? हेलो, अभी आवाज आ रही है? परफेक्ट. Now, okay. Chalo, 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 chalo. Thank you so much for your patience. Okay. Thank you so much for your patience. Thank you so much for your patience. Okay. So where were we? There was a technical glitch. होता रहता है, इतनी क्लासेस चलती हैं, होता रहता है. ठीक है. There was a technical glitch. Thank you so much for your patience. Thank you so much for being here. Okay, 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 okay. Thank you, thank you, thank you. Now, I was telling you that the stress strain curve that we draw in order to understand ductile material behavior is a particular material called low carbon mild steel. Low carbon mild steel means the percentage of carbon in this mild steel is less. That's why we get this region. If I increase the percentage carbon, then this region will be gone. So in a lot of ductile material, we don't get this region. ये वाला जो region है, ये वाला जो particular region है, this region is not present in every ductile material. For example, if you draw the stress strain curve for aluminum, then you will not get this region. You will not get this region. If you draw the stress strain curve for aluminum, then you will get this curve. Okay. So what is happening here? Understand. In case of low carbon mild steel, the material becomes elastic to plastic gradually. There is a gradual transition from elastic to plastic. You can see that transition here. यहाँ पे वो transition आपको दिख रहा है, right? यहाँ पे वो transition आपको दिख रहा है. So you can pinpoint the point at which the material became plastic, right? आप यहाँ पे बता सकते हो कि material जो है elastic से plastic कब convert हुआ. But in case of aluminum, there is no particular point at which the material became elastic to plastic. There was a sudden change into elastic to plastic. So we cannot pinpoint exactly where is the yield point. So here the definition of yield point is a little different. What is the definition of yield point here? Let's say you want to find the yield point. So yield point is considered as the point at which there is a permanent deformation of 0.2%. The point at which there is a permanent deformation of 0.2%. Now how I am going to find that point? Understand. So let's say this is the yield point. Let's say this is the yield point. So beta, if I draw the unloading curve from here, then it should meet at this point 0.2%, because there is a 0.2% permanent strain at yield point. मैंने आपको बताया था यहाँ पे that if I unload the curve, then it meets at epsilon permanent. So if I unload the curve from yield, then it meets at 0.2%. So what I am going to do is I am going to reverse this. अब मैं इसको reverse करने वाला हूँ. How I am going to reverse this? I am going to draw a line, a straight line from 0.2%. I know where 0.2% epsilon is. So I am going to draw a straight line from 0.2%, and this line should be parallel to this line because the slope should be equal to E. तो ये वाली line के parallel मैं एक line खींचूंगा, and the point at which it meets the curve will be called as yield point. So this is how we find yield point in case of aluminum or any other ductile material which does not show this region. ये वाला region जहां नहीं है उसको हम उस केस में हम ऐसे yield point निकाल सकते हैं. So is this point clear to you guys? क्या ये point clear है? In case of aluminum or other ductile materials, how to find the yield point? Because you might get theory questions from this. Okay, इस concept से theory question आपको आ सकते हैं, तो आपको ये concept पता होना बहुत जरूरी है. So is this concept clear to you? Is this concept clear to you? Yes. Very good, very good, very good, very good. बहुत बढ़िया, बहुत बढ़िया, बहुत बढ़िया. सौरभ, आकाश, शालिनी, अथर्व, स्निग्धांजलि, thank you so much for being patient. Okay, this is a virtue nowadays. This is a characteristic nowadays. ये एक बहुत important characteristic है एक इंसान के अंदर. Patience होना चाहिए जो आजकल लोगों में नहीं है. Okay, people have lost their patience nowadays. They can't even wait for 30 seconds on signal. ठीक है, आजकल लोगों में इतना कम पेशेंस है कि 30 सेकंड्स के लिए सिग्नल पे वेट नहीं कर सकते. आजकल लोगों में इतना कम पेशेंस है कि वो 1 मिनट का वीडियो भी पूरा नहीं देख सकते. ठीक है, उनको सीधे पॉइंट पे आना है. स्किप करो. सो दिस इज द पेशेंस लेवल ऑफ पीपल नाउअडेज. ओके, तो इसीलिए व्हेन देयर वाज अ प्रॉब्लम, टेक्निकल प्रॉब्लम, पीपल कुडंट इवन वेट फॉर 2 मिनट्स फॉर द प्रॉब्लम टू रिजॉल्व. अभी अगर आप लोग क्लासरूम में बैठे होते और लाइट चली जाती, you would have waited for 10-15 minutes, right? If you are sitting in a classroom, okay, and if the electricity is suddenly gone, you would have waited for at least 10-15 minutes for the electricity to come back, for the power to come back. If it doesn't come back in a few minutes, then you leave. But here in online classes, we don't have a patience for even 1 minute 2 minutes, we can't even wait for 2 minutes. As soon as there is a little difficulty, as soon as there is a little problem, people suddenly leave. So if you keep doing this, where is the discipline? वो डिसिप्लिन कहाँ है फिर? आप लोगों को ऐसे करके गेट नहीं मिलेगा ना, आप लोगों को ऐसे करके स्कोर नहीं मिलेगा. So you need a little patience, you need discipline. If you are disciplined, then only you will be able to score. वो थोड़ा सा भी डिसिप्लिन अपने अंदर अगर नहीं लेके आएंगे हम लोग, तो फिर हम लोग गेट जैसा टफ एग्जाम, कॉम्पिटिटिव एग्जाम कैसे क्रैक कर सकते हैं? See, every year there will be at least 2 lakh people from mechanical alone who will be filling the GATE exam. And now, as there are third year students also allowed in GATE exam, there will be more than 3 lakhs people filling the form of GATE from mechanical alone. So beta, you are competing with those 3 lakh students. So you need to be extraordinary in order to score better. You need to be disciplined, you need to be hardworking, you need to be patient. ये चीजें अगर अपने अंदर नहीं डेवलप करेंगे तो फिर हम लोग कैसे एक्सपेक्ट कर सकते हैं वो 3 लाख लोगों के साथ कंपीट करने का? हाउ वी आर गोइंग टू कंपीट विद दोस 3 लाख पीपल इफ वी आर नॉट इवन डिसिप्लिन्ड अ लिटिल? थोड़ा सा डिसिप्लिन भी अगर अपने अंदर नहीं लाएंगे तो फिर कहां से 3 लाख लोगों से कंपीट करने का सोच रहे हो? फिर ब्रेक छोड़ दो, सब कुछ छोड़ दो, इंजीनियरिंग छोड़ दो, पढ़ना लिखना सब छोड़ दो. ठीक है, कोई छोटा मोटा काम कर सकते हैं तभी जिंदगी चलेगी. अदरवाइज अगर कुछ बड़ा करना है जिंदगी में तो फिर ये डिसिप्लिन लाना बहुत जरूरी है अपने अंदर. इतना भी पेशेंस अगर अपने अंदर हम लोग डेवलप नहीं कर सकते, देन बेटा ये सब चीजें बेकार है. ओके, सो बेटा अगर अपने अंदर पेशेंस लेके आना है तो सबसे पहले यू स्टॉप स्क्रोलिंग योर फोन एवरी नाउ एंड देन. ये जो फोन को स्क्रोल कर करके हर 10 सेकेंड में एक नया कंटेंट देखने की जो आदत बन गई है लोगों में, this is why there is no patience in us anymore. This is why we can't even wait for 10 seconds at signal. आजकल आपने देखा होगा लोग 10 सेकंड भी सिग्नल पे वेट नहीं कर सकते. They feel like these 10 seconds are even more important than their life. That's why they cross signals. That's why they take such a huge risk for 10 seconds, for saving 10 seconds. So they are not saving 10 seconds. They just have lost patience. They cannot wait for 10 seconds. That is lack of patience. So beta, if you want to improve your patience level, if you want to improve your focus, then beta you need to stop scrolling your phone. You need to stop using these apps which need you to scroll. ये लगातार स्क्रोलिंग करने वाले जो एप्स होते हैं ना, मीम्स देखते जा रहे हैं, वीडियोस देखते जा रहे हैं, हर 10 सेकंड में 15 सेकंड में एक नया वीडियो. This is what is this doing? This is reducing your patience level. आपका पेशेंस लेवल कम होता जा रहा है क्योंकि आपको 10 सेकंड में नई चीजें दिखने, 10 सेकंड में नई नई चीजें देखने का आपके अंदर जो है वो एक नया शौक पैदा हो गया. सो दिस इज व्हाई वी नीड टू स्टॉप दीज काइंड ऑफ एप्स राइट नाउ. अदरवाइज इफ यू कीप डूइंग दिस देन यू विल बिकम वेरी इम्पेशेंट. ओके, चलो. So this is the stress strain curve for a ductile material. Is this clear to everyone? Now let's move on to the stress strain curve for brittle materials. Now beta, in case of brittle materials, there is no permanent deformation. And if there is no permanent deformation, you are not going to get yielding, you are not going to get strain hardening, you are not going to get necking. So what we are going to get? अगर yielding नहीं मिलेगी, strain hardening नहीं मिलेगा, necking नहीं मिलेगा, then what we are going to get? So beta, initially if you increase the load, there will be a straight line and after it will become slightly curved and then it will fracture. That's it. So this is the stress strain curve for brittle material. So simple, right? Initially it will be a straight line up to this point, up to proportional limit, and then it will fracture. A will be the proportional limit. A will be the proportional limit and B will be the fracture point. That's it. So this is the stress strain curve of a brittle material. Very simple, and you can see the total strain is very small compared to ductile material. Ductile material में देखो कितना strain मिल रहा है. We are getting this much strain. And in case of brittle material, it is negligible. In case of brittle material, it is negligible. So that is the difference between ductile and brittle material. So do you understand the stress strain curve of brittle material? Yes. Thank you so much, guys. Thank you so much. But we need these types of motivations also from time to time, है ना? Time to time ये motivation, ये चीजें भी discuss करना बहुत जरूरी है. If you are competing for an exam, if you are competing with so many people, if you are preparing for such a competitive exam, such a level of competitive exam, then बेटा you need these things also. सिर्फ पढ़ाई करके, सिर्फ वो कंटेंट लेके, सिर्फ नोट्स बना के एग्जाम नहीं निकलता है. ये छोटी छोटी चीजें भी बहुत जरूरी होती, राइट? These things are also very important, okay, from time to time. So from time to time we arrange these type of sessions also, okay, and I am soon going to arrange a one-on-one session, not one-on-one session, an interactive session where we will talk, only we will talk. You ask question, I will answer your questions, okay? Whatever you want to know about me, about my preparation strategy, about my life experiences, whatever you want to know, you can ask me. So soon I am planning to take it this week only, okay? So I will arrange it soon, okay? All right, so this is the stress strain curve for brittle material. Now beta, what was our final objective from stress strain curve? Apna final objective kya tha stress strain curve se? Our final objective was to find certain material properties, right? So let's see what material properties we can calculate from these stress strain curves. इन स्ट्रेस स्ट्रेन कर्व से क्या प्रॉपर्टी हम निकालने वाले हैं और कैसे निकालने वाले हैं ये देखते हैं, ओके? नाउ बेटा, these properties are very important to understand from theory point of view as well as numerical point of view. You will get numerical also from stress strain curve. Stress strain curve is not just a theory topic, it is a numerical topic. You can see a numerical from stress strain curve in GATE 2016 or 17, I don't remember, in GATE 2019 also, okay? So beta, this is a very important topic for numerical also, okay? So beta, let's first understand the first property, which is a very important property of a material, which is known as strength. Now what is strength? What do I mean by strength of a material? नाम ही है इस सब्जेक्ट का, strength of material, right? The name of this subject itself is strength of material. So what is strength of material? Strength of a material is the maximum magnitude of stress that the material can resist without failure. How much stress you can apply on this material without failing this material, that is known as the strength of that material. For example, if a material can maximum have 200 megapascal, after 200 megapascal it breaks, I will say that the strength of this material is 200. If you apply more than 200, the material is going to fail. So your maximum stress should always be less than 200. So this material will never fail. So this property is very important when you are designing a machine element. जब भी आप किसी एलिमेंट को, किसी भी कंपोनेंट को डिजाइन करते हो, whatever component it is a beam, it is a bar, it is a column, it is a shaft, whatever component it is, you need to know the strength of material so that the maximum stress is always less than this. Otherwise, what is going to happen? The material is going to fail. Now beta, there are two types of failure. In case of ductile material, if the material yields, we say that the material fails. अगर मटेरियल में yielding हो गई, हम बोल देते हैं मटेरियल फेल हो गया. Now why we say that the material fails if it yields? Understand, in case of yielding we get a very large plastic deformation, right? Yielding चालू हो गई मतलब बहुत large plastic deformation चालू हो गया. So beta, if there is a large deformation in the material, then the shape and size of the element is going to completely change. The shape and size of your component is completely going to change. And if the shape and size of the component is going to change, will it be able to function properly? क्या वो अपना काम ढंग से कर पाएगा? Will it be able to function properly? No, no, it will not be able to function properly, right? For example, let's say you have made a column, okay? It is supporting the beam. Now, if the column deforms, will it be able to provide the necessary support to the beam? No, it will not be able to provide that necessary support, and your beam will also fall down. So beta, that's why if the material yields, if there is a permanent deformation, large permanent deformation, we say bus, now you have to replace that machine element. So yielding is a type of failure. Although your material is not broken, it is not fractured, but it is failed, because now the size and shape is completely changed. So beta, if yielding is the failure, then the maximum stress you can apply without yielding will be known as yield strength. Yield strength का मतलब क्या है? Maximum stress you can apply on the material without yielding. Yield किए बिना मैं maximum कितना stress लगा सकता हूं? If my stress is more than this, then the material will yield and I will say that the material has failed. Okay, and it is denoted by SYT. I denote the yield strength by SYT. What is SYT? S stands for strength, Y stands for yielding, T stands for tension. Okay. Now, in some material, yielding is not a problem. For example, cast iron में तो कोई yielding ही नहीं है. So, beta, in case of cast iron, the stress, maximum stress you can apply without fracture is known as ultimate strength. So ultimate strength क्या है? It is the maximum stress you can apply without fracture. Okay, and it is denoted by SUT. S stands for strength, U stands for ultimate, T stands for tension. We are applying tensile load, right? So that's why these strengths are SYT and SUT. If your stress is compressive, then they will be denoted by SYC, SUC. Now beta, understand, if this is my stress strain curve, if this is my stress strain curve and this is the yield point, then this will be SYT and this is the fracture point. Now before fracture point, where do you get maximum stress? Here. So this will be SUT. Is it clear? So beta, if you have this curve, you can easily find SYT and SUT, right? Now understand this point. There are three strengths. SYT, SYC and SYS. This is yield strength in tension. This is yield strength in compression. This is yield strength in shear. So beta, right now we are only seeing tensile strength, but there is a compressive strength also under compressive load and there is a shear strength also under shear. Okay, now understand, for ductile materials, SYT and SYC are almost constant. Okay, both are almost same. Tensile strength and compressive strength in case of ductile material are almost same, but the shear strength is less. So they are weakest in shear. Ductile materials are weakest in shear. ये shear में सबसे ज़्यादा weak होते हैं. Their strength in shear is minimum. But in case of brittle material is different. This story is different. Brittle material के केस में ये story अलग होती है. In case of brittle material, the compressive strength is maximum, then the shear strength, and minimum is tensile strength. So beta, a lot of brittle materials have a very high compressive strength but a very low tensile strength. For example, concrete. In case of concrete, the tensile strength is 1/10 of compressive strength. Means if I can apply 1000 megapascal compressive stress, then I can only apply 100 megapascal tensile stress in case of in case of concrete. So concrete is used to make columns because columns are subjected to compression. But beta, concrete is not used where you need tensile load. If there is a tensile load, then concrete will fail early because their tensile strength is very less. Their compressive strength is maximum. So beta, you need to remember this. You need to remember this order. ये ऑर्डर आपको याद रखना है, ये ऑर्डर आपको याद रखना है फॉर डक्टाइल एंड ब्रिटल मटेरियल, बिकॉज देयर विल बी क्वेश्चंस फ्रॉम दिस. ओके, सो बेटा डक्टाइल मटेरियल्स आर वीकेस्ट इन शियर एंड ब्रिटल मटेरियल्स आर वीकेस्ट इन टेंशन. इज दिस क्लियर? इज दिस क्लियर? यस. सो बेटा दिस इज द फर्स्ट प्रॉपर्टी यू गेट फ्रॉम द स्ट्रेस स्ट्रेन कर्व. स्ट्रेस स्ट्रेन कर्व में सबसे पहली प्रॉपर्टी हम ये निकालते हैं. ओके, नाउ ductility. The next property is ductility. What is ductility? It is the ability of a material to deform plastically. Understand? Let's say this is the stress strain curve. Let's say this is the stress strain curve. Okay, this is point O, this is point F. Okay, so from here to here, the maximum deformation you are getting. How much deformation you are getting? That is the ductility of the material. Ductility of a material is the ability to deform plastically. कितना ज़्यादा plastically ये deform हो सकता है, that is known as ductility. Now understand why this property is important. How much plastic deformation can a material have? Why is this important? Understand. In some manufacturing processes, we need large permanent deformations in material. For example, wire drawing. In case of wire drawing, what happens? Wire drawing का मतलब क्या होता है? Wire drawing means you are making thin wires from a large body. किसी large body से thin wires बनाने के process को we call wire drawing. So बेटा, let's say you have this big material and you need to make thin wires of it. So you need to reduce the cross section of this body. ठीक है, अपने पास मान लो इतनी बड़ी बॉडी है और इसके पतले पतले वायर बनाने हैं. So you need to make thin wires of this body, and in order to make thin wires you need to reduce the cross sectional area, and when you are reducing the cross sectional area, the material should not fracture. If the material fractures, you will not be able to make wires. So beta, in this case you need a ductile material, a highly ductile material which will elongate plastically, जो बहुत ज्यादा plastically elongate हो सकता है without fracture. So do you understand what do we mean by ductility and why it is important? It is the ability of a material to deform plastically without fracture. बिना fracture हुए material कितना deform हो सकता है, and how it is calculated, whether the material is ductile or less ductile. How it is calculated? It is calculated by two different values. Either you calculate percentage elongation. What will be percentage elongation? It will be LF minus LO by LO into 100. Final length minus original length by original length into 100. Or you can also calculate it using percentage reduction in area. So it will be A original minus A final by A original into 100. Now beta, here I am writing L final minus L original. Here I am writing A original minus A final. Why? Because length is increasing but area is reducing. Okay. Now understand, we need the material which can deform plastically, not elastically. Why? Because if you want to make wires, when you remove the load, it should not again regain its shape. Now, so beta, plastic deformation should be high. Plastic deformation should be high. So beta, there will be a question in theory, which one is more ductile, steel or rubber? So usually people think that rubber is more ductile because it can elongate a lot. But that elongation is temporary, that is elastic deformation. We need permanent deformation. Nah, we don't want the material to regain its shape. So beta, there should be permanent deformation. So steel is more ductile than rubber because in case of steel, the permanent deformation is high. In case of rubber, the temporary deformation is high. So is this clear? Why the steel is more ductile than rubber? Why the steel is more ductile than rubber? क्या ये क्लियर है? क्या ये क्लियर है? क्या ये क्लियर है? यस, यस, वेरी गुड, वेरी गुड, वेरी गुड. चलो, नेक्स्ट इज रेजिलियंस. नाउ व्हाट इज रेजिलियंस? It is the ability of a material to absorb strain energy without permanent deformation. What is resilience? What do I mean by resilience? It is the ability of a material to absorb strain energy without permanent deformation. Understand it? Understand it. What do I mean by strain energy? Strain energy means when you apply the load, the material deforms. So the energy absorbed due to this deformation is known as strain energy. Understand the word beta, strain. So it is the energy due to strain. So when I apply the load, the material deforms. So due to this deformation, there is some energy inside the material. So this energy is known as strain energy. Just like spring, when the spring gets deformed, it absorbs some energy, right? Half kx square. So that energy is known as strain energy. It is a form of potential energy. Okay? Now, how much energy a material can absorb without permanent deformation is known as resilience. Now understand why this property is important. अब resilience क्यों important है? Why resilience is important? Understand this thing. In case of impact load or vibration or shock, what do I mean by impact load? Impact load means moving load. Static load means load which is not moving. Impact load means load which is moving. For example, if you hammer, then that is an impact load. जब आप हैमरिंग करते हो, when you strike a body with a hammer, that load is impact load. Okay, but if this body is kept on this another body, then this weight of this body is a static load because it is not moving. But if I drop it from some height, then it becomes an impact load because it strikes the body with some velocity. So this is impact load. Now in case of impact load, if you want the material to sustain the load, it should absorb the energy of the load, right? अगर आप चाहते हो कि ये मटेरियल इस लोड को absorb कर ले, इस लोड को सह ले, इस लोड को sustain कर ले, then it should absorb the energy provided by the load, right? When you are hammering a body, you are providing some energy. So if it absorbs all that energy, it will sustain the load. So beta, this property is important in case of impact loading. So in case of impact loading, if you are designing a machine element, then you want a resilient material. अगर आप किसी element को impact load के लिए डिजाइन कर रहे हो, तो वो material जो है, वो जो body है, वो resilient होनी चाहिए. For example, springs. Springs are subjected to impact load, right? Springs are subjected to impact loads. So if you want a better spring, then beta, the material of the spring should be resilient. Resilient means it should absorb maximum amount of energy without permanent deformation, okay, without yielding. So beta, understand how we are going to calculate it. So beta, in order to find how much a material is resilient, we calculate modulus of resilience. Now what is modulus of resilience? Modulus of resilience is strain energy per unit volume up to yield point. Modulus of resilience is strain energy per unit volume up to yield point. Yield point तक maximum कितनी strain energy per unit volume it can absorb. That is the modulus of resilience. And how it can be calculated? From stress strain curve. Understand it. In case of stress strain curve, the area under the curve is equal to strain energy per unit volume. Area under the curve is equal to strain energy per unit volume. ये जो area है, this area is strain energy per unit volume. Okay. So what will be the strain energy per unit volume, beta? What will be this area? This area will be half into base into height, है ना? This area will be half into base into height. Now beta, what is the stress? sigma. Let's say the stress is sigma and the strain is epsilon. So beta strain energy per unit volume will be equal to half into base into height. Now beta, up to this point the stress strain curve is linear. So can I write epsilon equal to sigma by E? So strain energy per unit volume is sigma square by 2E. So what will be the modulus of resilience? What will be the modulus of resilience? Modulus of resilience will become, sigma will be what? Up to yield point matlab sigma will be SYT. So it will become SYT square by 2E. This will be modulus of resilience, SYT square by 2E. So beta, if this value is very high, then the material will be able to sustain more amount of impact load. जितना ज्यादा ये वैल्यू रहेगी, मटेरियल उतना ज्यादा इम्पैक्ट लोड सस्टेन कर पाएगा. ओके, व्हाट इज impact load, what is suddenly applied load, all this I will explain. Okay, when the time will come I will explain all this. So don't worry about impact load versus sudden load. All these are different. Impact load and sudden load, they are slightly different, their definition is slightly different. I will explain it. Okay, I will explain it. So don't worry about that right now. Okay, now beta, understand this. Sometimes instead of stress strain curve, you will have load deflection curve. Okay, sometime instead of stress strain curve, you will have load deflection curve. So if the load deflection curve is given, then the area under the curve is known as strain energy, not strain energy per unit volume. The area under the curve in sigma epsilon curve is strain energy per unit volume, and area under the curve of load deflection is strain energy. Is it clear? Strain energy per unit volume. यहाँ का area निकालोगे you will get strain energy. यहाँ का area निकालोगे you will get strain energy per unit volume. Is it clear to you? Because there has been a numerical on this. इसके ऊपर एक numerical आ चुका है. We have a numerical on this. Okay. Now we are clear about resilience, right? So the next property is toughness. Now understand what is toughness. Toughness is ability of a material to absorb strain energy without fracture. It is very close to resilience. Resilience and toughness are very similar. Only difference is, in case of resilience, we say that the material should absorb energy without yielding, and toughness means ability to absorb energy without fracture. So the difference between yield strength and ultimate strength is same as difference between resilience and toughness. Yield strength में हम लोग yield point तक का strength देखते हैं, ultimate strength में हम लोग fracture तक का strength देखते हैं, right? तो बेटा यहाँ पे भी resilience में we say maximum ability to absorb energy up to yield point. Here ability to absorb energy up to fracture. Okay. Now beta, here also in order to calculate toughness, there is modulus of toughness, which will be equal to strain energy per unit volume up to fracture point, right? And how you are going to calculate it? How you are going to calculate it? By area under stress strain curve, right? And this time you have to find the total area. You have to find the total area. But for this we don't have an equation. इसके लिए अपने पास कोई equation नहीं है. For this we don't have an equation because beta, for this curve we don't have a direct equation. We have this curve. This is a linear curve, so we can calculate the area under this linear curve. But ये जो curve आ रहा है, we cannot calculate the area under this curve. So we cannot find a particular equation for modulus of toughness. For modulus of resilience, we have equation SYT square by 2A. But for modulus of toughness, we have to find this total area. Okay. So is this point clear? Are these properties clear? What properties you can calculate from stress strain curve? We can calculate strength, we can calculate ductility, we can calculate resilience, we can calculate toughness. Okay. Other material properties are calculated by other types of test. From simple tension test, we can calculate these many properties. Okay. तो बाकी की जो properties होती हैं, उनको निकालने के लिए we have other types of testings. Okay. So we only need to understand these material properties which are based on simple tension test, based on stress strain curve. Okay. Now beta, a very important topic is there related to stress strain curve, which is true stress strain curve and power law. So true stress strain curve and power law I will explain tomorrow. Tomorrow's class I will explain true stress strain curve and power law, and from tomorrow we are going to start numericals. Tomorrow I am going to start the chapter of axial load. So from tomorrow we are going to start the calculation of stress and strain. कल से बेटा calculation of stress and strain चालू होगा, means we will start solving numericals from tomorrow. So beta, whatever theory you had to know, we have covered in these 5 lectures I think, right? Introduction to stress part 1, part 2, introduction to strain, then material properties part 1, material properties part 2. So in these 5 lectures we have covered all the theory, all the basic concepts you require. The other concepts will be discussed in other chapters, and from tomorrow we are going to start the calculation of stress and strain. So beta, from tomorrow you will require calculator with you. Okay, till now you never had to put calculator in your hands, but from tomorrow you are going to need calculators in your hand, because from tomorrow we are going to start lots and lots of numericals. We will solve varieties of numericals in the class. Okay, अलग-अलग type के numerical, अलग-अलग variety के numerical हम लोग करेंगे. Okay, we will also solve numericals from previous year GATE exam. Okay, we will solve numericals from GATE ME, we will solve numericals from GATE XE also. Okay, chalo. So beta, true stress strain and power law I will explain in tomorrow's class. Okay, and beta, join this Telegram channel Approved 10. If you have still not joined, please join this Telegram channel Approved 10, because beta, from tomorrow we will also conduct special classes, free special classes, where we are going to solve the additional numericals. Okay, because beta, in class it is not possible to solve a lot of numericals. So additional numericals I will solve in special classes, free special classes on Unacademy app. So beta, in order to get the notification of those classes, what you need to do is join this Telegram channel, because I will put the schedule, I will put the notification in this channel itself. Okay, so beta, go to your Telegram app and search for Approved 10 and join the Telegram channel, or you can just scan this QR code and you can join the Telegram channel. Okay, and if you want to download the lecture PDF, then just go to tinyurl.com/approved10 and you will find these Excel sheets of different subjects. So you just find the Excel sheet of strength of material. What I have done is I have prepared lecture by lecture the Excel sheets where you can find the YouTube class and the PDF link. The link of YouTube class and the link of PDF. So there is an Excel sheet of engineering mechanics. This is a complete subject. Excel sheet of machine design, again complete. Strength of material, I am just taking the classes. So I am updating the link after every class. So beta, after this class also in 10-15 minutes, you will get the link to download the PDF. Okay. And if you like my teaching style, and if you want to learn more from me, if you want to talk to me on one-on-one basis, if you want to ask your doubts personally, then beta, come to Unacademy Plus. This is such a personalized learning platform that you will feel like you are sitting in front of the educator, which is not possible anywhere else. और किसी भी platform पे ये possible नहीं है कि आप इतना ज़्यादा interactive और personalized learning कर पाओ online. But here beta, on Unacademy, online, you will feel like you are sitting in front of your educator. So it is that personalized, it is that interactive. So you get live classes in English as well as in Hindi. So there is no problem with language. Every class is in Hindi as well as in English. Then there will be doubt clearing sessions, and these doubt clearing sessions are very interactive. Understand how? Can you see this image? This is the image of a question which is sent by a student to his educator. So you can send whatever questions, whatever doubts you have in the picture form in this app. So your educator will see that question and he will answer your queries live in the class. So it is just like showing your notebook in the class. जैसे आप लोग notebook show करते हो classroom में, sir, whether I have done this correctly or not, sir, how to solve this problem. So you can do that in the live class on Unacademy. That is the power of Unacademy, and a very amazing feature on Unacademy which is known as live polling and leaderboard. Now what is live polling and leaderboard? Whenever there is an objective question, A, B, C, D is answer. So we create live polling where you can answer where you can choose one option, and beta, whether you are correct or not, what is your ranking among the students, what is your timing, all that will be shown on this leaderboard. Can you see? This is the poll leaderboard. So here the rank of student is given and the timing of students is also given. He answered in 8.6 seconds, he answered in 7.3 seconds, 11.3 seconds. So beta, this is the timing of the students. So beta, this is the live poll leaderboard. So these kinds of features are there to improve your ability to answer in time, your ability to choose correct options, and this will create a very interactive environment in the class. So beta, that is the power of Unacademy, and you will have crash courses for different exams. You will not be only studying for GATE and ESC. You will be studying for various exams. You can see multiple batches. These are just few batches. These are just few batches. You can see me in every batch. These are just few batches. There are lots and lots of batches for different exams, for different students at different time. So you can join any of them, you can join all of them. There is no limit on learning on Unacademy. One subscription and infinite access, complete access. Okay. So beta, just go to your Unacademy learning app, click on plus, choose your category GATE and ESC and click on get subscription and choose your subscription plan. Now 1 month, 3 months, 6 months, these are short plans, but they are not very effective because their per month cost is very high. If you choose 1 year or 2 year subscription, what happens is, first, the per month cost is very less, and second, even if 3 months and 4 months later the GATE will be over, you will still have your subscription and you can prepare for other exams. There are other batches for other exams, ISRO, BARC, DRDO, ESC, different types of exam, different types of batches. So you can join those batches and you can continue your preparation. Okay. And if you use this referral code APPROVE10, then beta, you will get instant 10% off. So beta, you don't have to pay 25,000. You will only have to pay 22,500 for 1 year and 27,000 for 2 years. And as soon as you put this in your application, I will get the notification. You will be connected to me. You will get complete guidance. You will get complete mentorship from me. So you will be connected to me if you use this code APPROVE10. This is a bridge between you and me on Unacademy Plus. And the best thing is you can also pay this fee in EMI, which is completely no cost EMI. So beta, if you want to pay this fees in EMI, you don't have to pay anything extra. 22,500 divided by 12. So 1 year EMI means 1875 rupees per month. No extra cost. No extra cost. Only 22,500 rupees you have to pay in 1 year. But don't forget to use APPROVE10. This is your referral code. If you use this code, you will be connected to me. You will get direct mentorship, direct guidance from me. Thank you so much, guys, for joining. Thank you so much for listening. Keep showing this support. Keep showing this love towards this subject, towards me. Thank you so much, guys. Beta Brijesh, you don't need to calculate the modulus of toughness from stress strain curve. Okay, so don't worry about that. Don't build questions in your mind. Okay? First, you see what type of questions you get in exam. Have you seen previous year questions from these topics? No, na. So just see the previous year question and then decide, okay, this question can be solved by this question can be solved by this. हवा में सवाल मत बनाओ. हवा में ताजमहल बनाओगे तो बेटा ढह जाएगा. Okay. Thank you so much, Abhijit, for the appreciation. Thank you so much. Hit the like button before leaving. Hit the like button before leaving. 200 के पार ले जाओ. Anything else? और कोई सवाल? Okay. Thank you so much. Bye bye. Good night. I will see you tomorrow at the same time, 7:30 p.m. Bye bye everyone. Bye bye.